Say your host now.
Yeah, thank you. Can you hear me okay?
So,
Yeah, Durga, the other guy is still not there. You want to check with the
sir, I'll check right away.
okay. And Pritham audio is not connected. Send a message in the group, no, that class has started. Huh? You're not in group. I think they don't have a group, I guess. Yeah, Pritham, can you hear me now?
I can hear you.
Perfect. I think we'll get started. We're waiting for you to connect your audio. Okay. Let me share my screen. Okay, guys, you should be able to see my screen. This is the Google Drive link which you have got yesterday, right? So,
Yes, sir.
yeah, so we'll be using this link and so that.
sir, Rupendra will not be available for a couple of days, but he will be looking at the recordings later. So he'll be joining by Thursday or something.
Sure. Thanks.
Thank you, sir.
Thanks, Durga. We'll continue, guys. Okay. So, yes, so now we will move on to designing a database. Okay. Give me a situation, give me which database you want to design, and we'll create and the database now. And there are a few concepts that we discussed yesterday. We will discuss while creating this database.
Okay.
So give me a database that you want to have.
Well, any basic database with names and numbers.
No. You tell me the situation. I will tell you whether it is names and numbers.
Okay.
What environment, what business, okay, what's your objective?
Well, knowing the conducting a survey between a group of people living in a community.
It's too small. For that, why do you need a database?
But
For Excel would do for that.
when we create a database of the shopping mall, it's having a position of 100 employees.
Shopping mall, okay, so employees and what else?
And they're having multiple branches in multiple locations.
Okay,
And their average sale and can you have anything?
mall sale. Now mall will not
Shopping.
have sale, right?
Shopping, like shopping center. Like,
Products inventory.
you can take
Products inventory also. Maybe we will take Ratndeep kind of
yeah,
thing.
we can take Ratndeep
Okay.
or KLM shopping mall
Okay,
like that.
so let's say we will design something like for a grocery store, okay? They have multiple branches,
Multiple branches, multiple products availability.
right? They'll be selling online and offline. Okay. Okay, so let's do that. So let's call it as Apna Mart something, right? So it's a grocery store with multiple stores, right? Grocery store, multiple locations. Okay. So now what all information will it have to carry? Okay. It has to have data about its employees. Correct?
Data,
It has to have data about its employees. It has to have data about the locations. Okay, it should know which location the stores are located in, right? Then it might have data about
the products available in the location.
inventory. Okay, so they'll have inventory data. Okay, now inventory. Okay, okay. So when we get down to inventory, we'll talk about it. And then also you need to have transaction data, right? Transaction data is when your inventory is being used up, right? So your inventory is being used up. Yeah, let's make this simple. Generally, when you talk about table, right, these are your information that you want to carry, okay? Obviously, will they get converted into table or not? We will see. Okay. So these are, okay, employees. Then you have locations, inventory, transactions, okay? So let's say these are the things that we want to capture. We are not talking about revenue as such, right? Because inventory will only have inventory count and maybe the buying price or something, but okay, we are not talking about this thing, okay? So which is fine, okay? As we go deeper into this, we will get to have more information. Okay, so let's start, okay? Let's talk about employees first. Okay, so employees, okay, what data you want to store here? Okay, employees, you will have employee ID, right? Employee ID, you need to have name, phone, email,
Location is working
date
in.
of birth, okay, location,
So, salary.
salary. Okay. So let's say these are the things that we want to have in terms of employees. Then we go down to next one, which is locations, right? So let's go step by step. Location. So in location, you want to obviously have the location name, right? Address, let's say, city, pin code,
State.
right? Location manager, right? Location manager, right? Somebody who is managing the location so that if any problem is there, you know whom to approach. Okay. We'll come back and add more if required. Then you need to have inventory, correct? So inventory, okay. So you'll have product name, right? You'll have product category, right? Okay. Then
Number of items.
buying price, yeah, number of items. Okay. So say quantity. Okay.
Selling price.
Buying
price and selling price.
Selling price will vary, right? Look, okay, let's say buying price. And in fact, buying price will also vary, but let's say we have buying price. Product name, But again, inventory, you also need to know which location inventory is stored in, right? So you will have multiple product, but
Multiple
at
locations, but
different locations also, right? So you need to also have locations.
each location should be, for each location, the inventory must be.
Yes. Correct? So you'll have locations also, right? Okay. Then transactions, right? So what all information do you want to keep in the transaction?
See.
Inventory,
Opening and closing stock.
No, opening and closing stock will not be there. It's opening and closing stock will be there in your inventory, not here, right? Here, okay, you bought one packet of biscuit, right? So it will have biscuit that is sold, right? Biscuit sold. Then you will have, let's say, bill number, right? On, let's say, if 10 people has bought the product, okay, you need to know the bill number, right? So bill number, that way you will be able to keep track.
Then the total is total number of bills,
Huh?
total number of bills.
No, why do we need total number of bills? Total number of bills we can calculate, right? Database will not have total. See, database is to store information. Total bill will change every second. Why do you want to have database for total bill? Total bill you can calculate, no?
Sorry.
No. Bill number, if bill number 1, 10 items are there. Bill number 2, 20 items are there. Bill number 3, 5. So you can actually count the bill number, right? Why do you have to store separately?
Total value of the bills.
Total value also can calculate here, no? So you have inventory, you have the bill number. So you know that, okay, bill number 101, how many items got sold? These 10 items. You can calculate. You don't need to store that. Okay. Things which you can calculate, for example, age. Age will change every year, right? So there is no point of having an age here. Instead, you'll have date of birth. You can easily calculate date of birth. Okay, date of birth, you can have date of joining. Okay. So things which you can calculate, you will not put in the database. It's a waste of time, waste of space, waste of everything. And second thing is, okay, now let's say, remember we spoke about yesterday, unique information should be stored in every cell. Okay. If I give here total value, how will I save the total value? Can you imagine total value? How will you create the table for total value? Okay, let's put total value. We'll come back to it. Okay, so now transaction, bill number, and also the employee who, sold, right? Okay. Okay, so let's say these are the things. Now let's start building table and see if we can build the table or not. So, okay, the two important things in database design. One is called E, other is called R. E is, okay, E is entity. And R is relationship. Okay. E is entity, R is relationship. Every unique set of information. Okay. Every unique thing which has its own features are called entity. So entity gets converted into tables. And relationship is what we build. Okay, we try to connect, okay, multiple tables. So in relational database, RDBMS, all tables have to be linked. Directly or indirectly, all tables are linked. Okay. Otherwise, there is no point of, or you can't get information. Okay. We'll see that when we go to relationship. Okay. Now coming back to this place here. Where? Here, right? Employees. Now let's start creating. So this is an entity because it has its own set of features that we calculate, we have analyzed, right? So we have analyzed its own set of features. So now what we need to do is we need to create a table. Okay. So employees will become a table. So we'll have a table with employees. Okay. Now let's create a table. Okay. Let's do that. I should have counted the columns, but let's see. Okay. So first column, we will put EMP-ID, right? And we'll have one, what do you call one, sample data also, maybe 1 or 2. Okay. We'll create 1 or 2 sample data also. Okay. So we talk about EMP-ID. We said name, we said phone number, we said email, we said date of birth, date of joining, location, and let's say we said salary. Okay. Okay. Now let's start putting some information here. One, employee ID 1, employee ID 2. Okay. Now employee ID 1, we'll put name as Sachin, and let's say Virat. Phone number 234-254. Email sa@sa.com. Let's say we put vi@sa.com. Right? Date of birth. Okay. Date of birth. Let's say we give 12-Jan dash. Okay, this is how we generally write in MySQL. Okay, so there is one more thing. We said that, right? 99% of the time, okay, 99% of the time, okay, that there is no difference between Oracle, MySQL, that's what we said, right? But there is 1% of the time that things will be different, even for development. We said that admin is totally different. But developer, there's an overlap between Oracle, SQL Server, MySQL, right? 99% of the stuff is same, but 1% stuff is different, okay? You have to keep in mind. One such difference is how to handle date. Oracle handles date differently, MySQL handles date differently. Okay, when we create actual database, we will see. Okay, so 12 Jan, let's say 1978. And here we'll say 15th August 1998. That's okay. Okay. Date of joining, let's give same date, or we can give different date. 1 Jan 2023. Here we will say 12 July 2024. So 4 has not been there. We'll make it 3 and we'll make it 2 here. Okay. Location. Now let's say you have location in your location is only in Miapur, let's say. I mean, sorry, Hyderabad, let's say. So we'll put here Miapur, and let's say here we put Banjara Hills. Okay. Salary, we'll put here 55,000, and we'll put here 48,000. Okay. So this is our sample table. Okay. Similarly, we have to create table here also. Okay. So again, insert table 5 columns. Okay. Here 5 columns. So insert table 5 columns. We will go here. Insert 4 columns, right? Okay. So let's quickly fill in here. Location name. Okay. LOC name, I'll call it. Okay. Address. City. Pin code. LOC manager. Okay. So location name. APMYR, let's say. That's the name I'm giving. Apna Mart. Okay. Then address some building 1, some building 2, city, let's say it's all Hyderabad, right? Hyderabad, pin code 50050 500 019. I don't know, just guess some number. Let's say here it is Sachin, Miapur. No, Miapur was Sachin only, right? And here it's Virat, let's say. Okay. Now product name. Product name, prod category, quantity, buying price, location. So product name, we'll have oil 5 liter, same oil 5 liter. Okay. Product category is oil or grocery, right? So everything will be oil. Quantity you have is 15. Here you have 9. Buying price is, let's say buying price of all the oils will be same, right? And here it is Miapur. And you have Banjara Hill. Okay. Now coming here. Inventory. Okay. So inventory sold. Okay. Bill number. Total val. And let's say employee who sold it. Okay. Now you see inventory sold. Inventory sold. Let's say we say this one only. Oil 5 liter. Oil 5 liter oil 5. Bill number is different, right? Total. Now you tell me, how can I put total value here? Because bill number 1, or let's say we'll make it bill number 1 only. Okay. And this is Parle biscuit maybe. Okay. Now how do I put the total value? No. What value should I put? Total value is sum of these two, right? How can I put sum of these two here? Right? So you cannot say, I cannot put total here. Okay. I have to put price only or something else. Total value is what? You calculate. Okay, this is bill number one, then you calculate that it is total this much. I cannot total here. So total will not come here.
Can we include quantity sold, sir?
Yes, we can include quantity sold, right? If you include quantity sold, then you have to minus that from from the main thing. But yeah, let's do that. Quantity sold. So let's say quantity sold 2, 1. Employee is bill number 1, right? So it has to be same employee. Okay. So this is what we have designed. Okay, these are the entity. Okay, and so what happens? Okay, before you actually get down to, and when we go down, you'll see that there's a lot of flaws in this design. Okay, there's a lot of flaws in this design. Why there's a lot of flaws in this design? Because it is not implementable, and we will see why. Okay, so we create what we call as ER diagram. ER diagram is a visualization of all your tables here. Now, how many tables have we created? We have created 4 tables, right? So let me add 4 text boxes or shapes. We'll go with shapes. Okay, so we have, let's say, employee, Okay. Then we have transactions. We have inventory. Inventory and then locations, right? Locations. Okay. So there are few key things that you have to keep in mind. Okay. How do I uniquely call each value? How do I uniquely call each value? Okay. How do I call uniquely each value? What I mean is, you have, let's say you have employees with the biggest table, right? Let's say you have employees. I want to find Sachin's email ID. Okay. It is possible that you might have 10 Sachin. Correct? It's possible that you might have 10 Sachins. Then how do I find Sachin whom I'm interested in?
Based on his location.
No, same location can also have multiple Sachin.
Employee ID.
Employee ID, right? So there has to be, okay, so here you have employee ID. But what about, let's say here, inventory, right? So every table should have a unique, what we call as keys, like employee ID. Okay. So every table should have a value that is unique. Okay. Okay. Now, which is called as keys actually. Now, keys is a broader term, okay, which is used to uniquely identify. So if you talk about employee ID itself, okay, you can have, as you said, employee ID. Okay, you can have employee name plus date of birth, right? You can have email ID. You can have phone number. Okay, using these columns, I can call the employee. But what is the problem with phone number? What if employees do not have phone? Right? You can't say that everybody should have phone, right? I will hire only if they have phone, right? Maybe not all of them have same email ID and they are sharing their email ID. Possible, right? So sharing email ID, phone number can also be shared, right? Employee ID and let's say date of birth together, it is unique. Okay. So what we have, we call them as candidate keys. Keys are anything that will help you to identify value uniquely. Okay. Then you come up with candidate keys. Candidate keys are values which are possibly used for candidate keys. Okay. Keys which can become what you call as primary key. Okay, primary means what? Unique. One. You can't have two values as primary key. You can have multiple keys. You can have multiple candidate keys. Okay, but you will have primary key. Okay, which can become. So in this case, employee ID can also become primary key. Employee ID name plus DOB can also become primary key. So two possibilities. So we have to select only one, right? So the PK should be, okay, should be, okay, should be one column only. Now you can have multiple columns, not that it has to be one column, but we prefer least number of columns. Okay, you can have both email ID and DOB, two comes together. We can have primary key. You can have employee ID name plus date of birth plus date of joining. Let's say two Sachin can have same date of birth, but two Sachin having same date of birth and same date of joining is again difficult. So you can have 3 columns, 4 comes together also, you can make as primary key. But the preferred, okay, but what we prefer, is PK should be one column. If you're not able to have one column, then 2 columns. But generally what we do, we add an extra column to make it unique. Okay, so PK should be one column and, okay, it should be, okay, now see, should, that's what I'm saying. Should is not the right word, okay. What we prefer is one column, prefer, right? And numeric. Your integer basically. Okay, it has to be one column and numeric. Why one column? Because it is easy to handle one column. And why numeric? Because it is easy to handle numeric. So tomorrow if I ask you, okay, okay, before I ask you, okay, tell me, is it easy to search for a word in a dictionary or it is easy to search for a particular page number in a book? If I tell you find book in the dictionary, right? Why? Because see, number, you have only 10 digits to compare in your mind, 5, 6. But if you talk about alphabets, you have 26 things to compare. Oh, P and O, which comes first? P comes first or O comes first, right? So 26 times you have to compare one value. Smaller it is, better, easier it is, right? If I just give you 2 binary digits, it's easy to search, right? So even you can have text also as primary key. That's why we say prefer, okay, not should. Okay, you can have text also, but we prefer this because it is faster, easy and faster to deal with data. Now, in our practice, we'll create maybe 20, 30 data. But in reality, okay, you will have, like, if you talk about Indian Railways, talking about customers, crores of customer it will have, right? Now, crores of customer, if you are saving even 0.01 second, imagine the time that you can save. For each customer, if you are saving 0.01 second or 0.001 second also, so if you have to iterate through 1 crore customer, imagine the amount that you can save, amount of time that you can save. So database has to be secure, always available, but at the same time, it has to be faster. The reason we are learning design, database design, is that to make things faster. If you are not able to make things faster, nobody is going to use your system. If you connect to Amazon, it takes 5 minutes to log in. Will you again go back and use it? No. That's why good design will make your database faster. And whatever we are talking about is from OLTP perspective, right? How do you make overall system faster? Okay, so we are talking about primary key. Primary key, okay, every table should have primary key. Every table should have primary key. Now, that primary key has to be unique. And preferably it should be numeric and single column. So now let's go and revisit our design. Okay, let's start with employee. Employee ID, perfect. Okay, I think it meets both our criteria. Okay, it is unique. No employee, even if Sachin leaves the company, okay, that email employee ID will be reserved. If new employee comes, that new employee will not be given 1, right? So if it is 1, 2, 3, 4, 5, 100, if 100 first employee comes, you give 100 first only. If you leave also, your employee ID will remain as it is. Employee ID is not transferable. So I can see, okay, who has left, who is still there. So employee ID is unique and it meets our requirement that one single column and numeric. So we can leave this, okay? There's no change to be done here. Now, if I go to locations, so here location name, okay, what if they come up with another location in Miapur? They might have one more location in Miapur, right? So what you could do is you can say here Miapur, AM Miapur, you can't change the value, right? Let's say, you make this as AM Miapur 2. Possible, right? Okay. So here, okay. So some building 3, Hyderabad pin code will remain same and location manager will change, right? Let's say we put row here, right? So this meets our requirement of making it a primary key because one single column is enough for us to uniquely identify. Okay. But here the problem is with the search, it becomes difficult. Okay. Search, we prefer to have numeric column as primary key, not a text column. So in this case, we better add one more column, okay, which we call this as location ID. That's why every database, okay, or every table in the database will have something called as, if it is location, they'll have location ID. Employee, employee ID. Transaction, transaction ID, which will uniquely identify. Okay, I'll put 1, 2, 3. Now, this is not required from business perspective, but it is required for us from managing the database, technical perspective. Right? Business says, I'm okay with the location name. If you tell me location 2, they will not even know what is location 2. If you say AM Miapur, oh, AM Miapur is that one. AM Miapur 2 is that one. But location ID is there to make it technically, okay, making our life easy in terms of accessing the data, reading, writing. Okay, 2 operations we perform in database, reading and writing. So the primary key will make your writing and reading both faster. Okay, because see, even to read, I need to know which one. Out of 1 crore customer, you don't know which customer I'm talking to or which customer I want to update the information about. I have to go through entire 1 crore list. So faster you go through, better it is. So if I use employee ID with number, okay, it is faster because you only have like 10 number to look at, right? Okay, unit place 10 numbers, tens place 10 numbers. But when you talk about alphabet, it becomes 26 times you have to compare, right? A and Z, right? A to Z. So it is faster to work with a number. So we'll add a LOC ID. Similarly, here also we will add, okay, we'll say insert to the left, we will have inventory ID. Now, inventory ID, you see, okay. Now the problem here, you see the inventory ID. All 5 liter is same, right? All 5 liter is same. So I have to give same inventory ID here. Right? But the property of primary key is, okay, so we prefer, and the property of primary key, it has to be unique and not null. What is unique? Unique means, okay, the data in that column, if I say primary key, okay, I cannot have duplicate values. Okay, and I cannot have empty, null, blank, nothing. Okay, if I don't add here, the blank, no value, this is called null value in database. Okay, this is called null value in database. Okay, so if you talk about, okay, there are few terms that you need to understand. Okay, so column types. Okay, not data types. Okay, column types I'm saying, or nature. Okay, so first one what we heard is primary key, or let's talk about unique here. Unique, not null or null. Null allowed or null not allowed. Okay, null allowed or not allowed. So if I say not null, that means null is not allowed. You can't leave that column blank. Like name, for example. Name, I cannot leave it blank. I cannot have employee without name. So when I'm designing the table, I will say name has to be not null. If you don't say not null, if then null values are allowed. People can enter null values. But you will say not null. Okay, we also call these as constraints. Constraints. Okay, these are called as constraints. So constraints can be unique. Unique means duplicate values can't be entered in that column. But null can be entered. But null can be entered. For example, email ID, phone number. Okay. Now, email ID, phone number, you may not have phone number. So I can leave it blank. But if you have a phone number, it has to be unique. You can't have same number with somebody else. Email ID, for example. Email ID, phone number, they can be null. You may not have it. But if you have it, then it has to be unique, right? So example, we can say phone number or email ID, right? Not null, okay, is null allowed or not allowed? So if I say not null, example is name. Okay, so you can have duplicate name, but you can't be without name. Your name can be duplicate, but you can't be without name. Then primary key. Primary key is the value has to be unique plus not null, and you can define only one column or set of column. Only one set of column. Set also you can't have multiple set. One column or one set of columns as primary key. Okay, so unique plus not null, you can have multiple values. Okay, but even if you have two columns which meets the requirement, okay, let's say employee ID and let's say Aadhaar number. The Aadhaar number or PAN card number, for example. Aadhaar number is also unique. Everyone has unique. Everybody has to have Aadhaar number. Okay, so you might have Aadhaar number and employee ID both as unique plus not null. But you cannot define both as primary key. Primary means only one, right? So example, Aadhaar and employee ID both will be unique and not null. But only one can be primary key. You can choose, okay, either Aadhaar number or employee ID both. But we'll choose employee ID because employee ID is in our control, right? So we control. So we prefer employee ID as primary key, not Aadhaar number. But Aadhaar number also fulfills the criteria of not null and unique. PAN card number. But PAN card will have text. Again, primary key, what we prefer, number, not text. Okay. So you have primary key. Then you have other constraints like default. Okay. So set a default value when not provided with any value. Okay, so let's say you have a company operating from Hyderabad. 90% of your employees are in Hyderabad. Okay, you have sales guys all across India. but all your sales, not sales, but marketing, product development, everybody is in Hyderabad, let's say. So when you hire an employee, 90% chance is that he'll be in Hyderabad. He or she will be in Hyderabad, right? So what you will do, you will say default location Hyderabad. So if I don't enter the location, automatically database will update it to Hyderabad. Database will update it to Hyderabad, even if we don't mention it. Okay. Example, location.
Excuse me, sir.
Yeah.
Sir, it is getting late for me.
Yeah, sure. We'll end it
Yeah,
here.
yeah. Yeah, okay.
I thought we can do it for 2 more minutes, but we'll stop it here. Okay.
Yeah, yeah, okay.
We'll continue from here tomorrow.
Okay.
At the office, maybe. Okay. So yes. So we will stop here and we'll continue working on the same data tomorrow.
Yeah, okay. Thank you, sir.
Thank you. Bye.
Bye, sir.